The conversation starter you need is already built into your MCP server. You just need to fetch and display it properly. You'll see how to retrieve a multi-message prompt template by name, then iterate through each message to access its role and content. The pattern handles both plain text and structured content automatically, so you can focus on using the results rather than parsing them.
Async with client. Result equals await client, get prompt, conversation starter, topic, climate. Hash access individual messages. For I, message and enumerate, result, messages. Print, F message I+1. Print F role, message role. Print F content. Message content text if hasheader message content text else message content.
This demonstrates the template method pattern applied to AI conversation flows. The code retrieves a reusable prompt template named Conversation Starter and injects dynamic arguments to generate a complete message sequence, separating content structure from runtime data. What makes this distinctive is how it treats conversation design as a templating problem, where the server defines the flow skeleton and clients provide the context. The pattern works by externalizing message generation logic to the server, allowing clients to focus on data rather than formatting. When you request a prompt with arguments, the server merges your data into its template structure, returning a ready-to-use message sequence with proper role assignments and content formatting. This creates a clean separation between conversation design, server-side, and data provision, client-side, enabling consistent interactions across different use cases. This approach solves the problem of maintaining coherent conversation flows while allowing dynamic content. Instead of hard-coding message sequences in your client, you centralize the design logic, making it easier to update prompts globally or A/B test different versions. It's particularly valuable for applications needing standardized interactions, like customer support bots or data analysis assistants, where you want consistent structure but flexible content. Let's break it down line by line.
Async with client.
Async context manager pattern ensures the client connection is properly initialized and cleaned up after use, preventing resource leaks. The async with block handles both connection setup and teardown automatically.
Result equals await client, get prompt, conversation starter, topic, climate.
This fetches a pre-configured prompt template named Conversation Starter with the climate topic injected as context. The await handles the async RPC call to the FastMCP server, returning a structured result containing AI-generated messages ready for processing.
Hash access individual messages. For I, message and enumerate, result, messages.
This iterates through the API response messages with enumeration. The enumerate pattern provides both the index and message object, enabling numbered output while maintaining access to each message's full content.
Print F message I+1.
This prints a numbered header for each message in the sequence. The I+1 converts the zero-based index to a human-readable count, making the output clearer for debugging or logging.
Print F role, message role.
This prints the message's role, identifying whether it's from the system, user, or assistant. Critical for debugging conversation flows, as role determines how the AI processes each message.
Print F content. Message content text if hasheader message content text else message content.
This handles dynamic content access in message objects. The hasheader check safely navigates both text-based and raw content formats, preventing attribute error when the content lacks a text property. It's a defensive pattern for inconsistent API response structures. Prompt message handling pattern. The get prompt method bridges structured templates and dynamic AI conversations, automatically serializing complex arguments into MCP-compatible JSON while preserving simple strings. The Hassetter message, content, text, check handles both text-only and complex content types without breaking the flow. This pattern enables prompt reuse across different LLM backends while maintaining type safety through automatic serialization.
The message that carries no meaning becomes the container for all meaning.